This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is our third video on graphing the secant function, and we're going to do this graph, y equals 3 secant of 2x. So here's the technique I'm going to use. We're going to graph y equals 3 cosine of 2x, all right? And then we're going to draw our asymptotes by looking at the graph, and note that the maximum and minimum points of the cosine graph that you see will switch for the secant graph. All right, so we want to graph y equals 3 secant of 2x. Now remember, this will be the same period as it is for the cosine of 2x. So the period will be 2 pi divided by b. And note b is 2. So 2 pi divided by 2 is simply pi. So the period of this function is going to be pi. So when I make my x-axis here, we notice usually the period goes to pi. I'm sorry, normally it goes to 2 pi. This will end up at pi, a full period. So you might notice this would give us pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4 is pi. It gets a little messy, so I'm going to take those off, but remember you could write all those key points down. Now what about on the y-axis, what markings? This 3, let's see how I use this color. This 3 tells you when you graph the cosine that the amplitude is going to be 3. We don't talk about an amplitude of the secant function, by the way. So let's say that's 4, etc. So we have labeled our x and y axes. Okay, so first let's graph First let's graph y equals 3 cosine of 2x, okay? But we have to use dotted lines. All right? So remember the cosine, if you just did y equals the cosine of x, you start off at 0, 1. But at this case, we have 3 times 1, so it's going to start up at 0, 3. So the first point will be up here, and then it goes down, right, at this point. Next point ends up down over here, all the way down. That's our lowest point, back up, and it ends up here at pi 3. And I like to kind of finish and do a few more. It's easier for me to graph it when I have a few more points like this. So I like doing at least 2 cycles and kind of finishing it through here. Guess that wasn't really very good the way I did that last one, but hopefully you get the idea. Let's see, there we go. So I finish going through here if you want. So this is more than 2 periods. So here we have the graph of 3 secant of 2x. Now the problem is I really didn't leave myself a lot of room to do the secant function, so I'm going to move this graph down a little bit. Before graphing the function, I want to determine what my asymptotes are, my vertical asymptotes. So I'm going to write what they are here in a minute. What are the vertical asymptotes? Well, wherever it goes through the x-axis, remember the reciprocal of 0 is undefined, that will be the asymptotes for the secant function. So we have these vertical asymptotes. Whoops. I didn't go through where it's 0, 0. Right here. So So we have our vertical asymptotes. So remember how to write those as equations. Those are vertical lines. Those are the form x equals. And pick any vertical asymptote you want, the x value. You could pick pi over 2, 3 pi over 2, negative pi over 2. I always take the first one after 0 for the secant. So I have pi over 2 plus half the period. Well, the period is pi. So what would half the period be? Pi over 2. But it's pi over 2k, right? Because it's multiples of pi over 2. So pi over 2k or k pi or pi k, where k is an integer. So that means if I'm here at pi over 2, I have to add pi over 2 to get the next one over here. And that should make sense to you because remember, this is pi over 4, 2 pi over 4. I'm just writing the x coordinates, 3 pi over 4. So if you added pi over 2, that's 2 pi over 2, you would end up here at 3. I've said that. Oops. I meant to say this is 3 pi over 4, right? Because we have pi over 4. Here's where the pi over 2 would be right here, right? That's the x coordinate. That would be 2 pi over 4, which is pi over 2, and then this would be 3 pi over 4. All right, so those are our vertical asymptotes. And then from there, once you have those, it's easy to graph. We take the minimum and maximum values we see for the cosecant, and we chose those opposites. So if it's a minimum for the cosine, it's a maximum for the cosecant, and we've got this graph right here. Remember that you use the asymptotes as guidelines. So we have the period. Let's see, highlighter. Let's do this right. So the period is pi. The vertical asymptotes can be written this way. And then what about for the last thing we want to do is the range. All right? Starts at the going down forever and goes up to negative 3. Union starts again at 3 all the way to infinity. And there we have our range. So we have the graph, the period, the vertical asymptotes. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.